is Algebra 2, Unit 6, Lesson 6. And today we're going to talk about the sum and product of roots. Any quadratic equation has two roots. We learned when we talked about the discriminant that they could be two real rational roots, two real irrational roots. You could have one double root, or you could have two complex roots. And those roots have some properties about them that will help you generate the quadratic equation. So we're going to review a little bit first. I'm going to compare what we're going to get with our roots, and then we're going to see how that relates to the sum and product of roots. So I've got a couple examples here. I'm just going to look at these and basically I'm just going to find the roots, and then we're going to talk about the relationship between those roots when it comes to the sum and product rule. So if I have this, the easiest way to find the roots of a quadratic equation, if it will work, is to factor. So I'm always going to try that first. Then I know if factoring doesn't work, I can use completing the square or the quadratic formula. Factoring for this one, what factors of 8 subtract to give you 2? Well, that would be 4 and 2. So I have x and x, I've got 4 and 2, and the plus 4 and minus 2, because we know the signs are different. And I set each of those factors equal to 0, and I get x equals -4 and x equals 2 as my two roots. So here I have two real rational roots. I could have also found those with completing the square or the quadratic formula. With this one, I'm going to do the same thing, and remember, whenever we find the roots of a quadratic equation, the first thing we have to do is set it equal to 0. So 6x squared plus 7x minus 3 equals 0. And then if I try to factor that, 6 times 3 is 18. We're looking for factors of 18 that subtract to give you 7. Well, that would be 9 and 2. So if I'm looking for 9 and 2, to make 9 and 2 out of a 6, I would need a 3x and a 2x. And then 3 times what gives me the 9? Well, that would be 3. And 2 times what gives me the 2? That would be 1. My signs are different. The plus goes with the big number, or the 9, so I need the plus here and the minus there. And then I would set each factor equal to 0 and solve. So that would be x equals 1/3, and this one would be x equals -3/2. Notice these are two real rational roots as well. They involve some fractions, so that one's not quite as easy to go backwards with to find the quadratic equation with. So I'm going to show you, back when we did unit or lesson 1, we learned how to factor the quadratics, and then I think it was in lesson 2 we learned that if we have two roots, well, we can work our way backwards to generate that quadratic equation. So if I do that, I said, well, I would add this to the other side, so that would give me x plus 4. I would add the 2 or subtract the 2 to the other side, so that would be x minus 2. And then all I have to do is FOIL, so that would be x squared plus 2x minus 8. And if we look at that, we can see that, yeah, they are the same thing. I can generate my quadratic equation. But there's another relationship that is very important for you to see. It's a relationship that can be used for complex and irrational roots. And so that's why we want to learn it, because this method is real easy when you have real rational roots. But when you get into the irrational and the complex roots, this method is going to be very, very difficult to accomplish. So we need another way. So if you look at these two roots, they are -4 and 2. And what I want to do is I want to look at the sum and the product of those two roots. So I'm going to erase this. So if we look at these two, if I take those roots and I ask what is the sum of those roots, well, if you add those together, you get -2. And what is the product of the roots? Well, if I multiply those together, I get -8. Okay, now look at this relationship. The sum is -2 and the product is -8. Okay, so this leads me to a formula that we can use to rewrite our quadratic equations. Let's look over here. I could work backwards to go back and get the quadratic equation, but I'm going to try to use the sum and product thing here. So the sum of these two numbers, when I add these two numbers together, I get -7/6. And when I multiply them together and get the product, I end up with -1/2. And this one's not as easy to see the relationship between the quadratic equation and these roots, but they will in just a minute. Let's look back at this one. Notice that the sum, that -2, almost matches the b value. And notice that the product, -8, is the same thing as the C value. And there's a formula that you can memorize to help you with this. X squared minus the sum of those numbers times x plus the product of those numbers will equal your quadratic equation. And let's just look at this. The sum was -2, so we're going to keep the x squared. Minus a -2 would be a plus 2x, and plus a -8 would be a minus 8. That matches what we have right here. I want to do the same thing with this one. If I use that same formula, x squared minus the sum times x plus the product equals 0. Well, x squared minus the sum would be plus 7/6x plus the product, that would be minus 1/2. And now if you notice this, that's not in standard form because it involves fractions. So the only thing we need to do to get that in standard form is to get rid of the fractions. Well, how do you get rid of a fraction? You multiply by the denominator. And when I see this, I have two denominators here. I've got the 6 and I've got the 2. I'm going to multiply by the highest denominator. So I'm going to multiply both sides of this equation by 6. So when I do that, I have 6x squared plus 7x minus 3 equals 0. And if you look at what we've got, it matches. The sum and product of the roots is a way to generate your quadratic equation. So here I have 3 examples, and we're going to use this formula to try to generate the quadratic equation. If I add those two numbers together, -2 and 5, I get 3. If I multiply those two together, I will get -10. I have x squared minus 3x minus 10 equals 0. And I could factor that and see if that's what I end up with. What factors of 10 subtract to give you 3? Well, 5 and 2. And it would be a -5 and a +2, so we can see it works out. Now, here's the good news about sum and product of roots. Before, when we had irrational roots like this, the process of working backwards to get your quadratic equation is almost impossible. I mean, you can do it, but it's so easy to mess up and to make careless mistakes. Nobody wants to do that. So the easiest way to generate your quadratic equation when you have an irrational or a complex root is to use the sum and product rule. Now, these two roots, even though they're listed as 4 plus or minus the square root of 5, that is two separate roots. The two roots are 4 plus the square root of 5 and 4 minus the square root of 5. So what I'm going to do is I'm going to take those and I'm going to add them together first. Well, if I add those together to get the sum, I just add like terms. So 4 plus 4 is 8 plus square root of 5 minus square root of 5. Well, what happens to that? The square root of 5 plus negative square root of 5, or square root of 5 minus square root of 5, is 0. So the nice thing about irrational roots here is since you have the plus and minus, they're going to cancel each other out every time. So the sum is just 8. Now for the product, if instead of putting a plus there, I multiply these together, I'm going to FOIL. Well, look what happens here. Notice these two things are conjugates. In fact, this is something important when you're dealing with quadratic equations. If you have one irrational root, the conjugate is also going to be one of the irrational roots. When we multiply conjugates together, remember, that was a way we used to get rid of the radicals on the denominator. If we multiply these conjugates, well, 4 times 4 is 16. And 4 times negative square root of 5 is negative 4 square root of 5. 4 times positive square root of 5 is positive 4 square root of 5. So those middle terms cancel out. Since the middle terms of conjugates canceled out, there's really no need to do those anymore. And then square root of 5 times negative square root of 5 is going to be minus 5. So we have 16 minus 5, which is 11. So the product here is 11. So even though we had a very messy set of roots, the sum and product of those roots is very simple. And then I plug into the formula to get my answer. So I've got x squared minus the sum, so that's minus 8 times x, plus the product, plus 11, equals 0. If you have complex roots, they work very similar. The two roots here are 2 plus I and 2 minus I. So think about that. If you add those together to get the sum, 2 plus 2 is 4. I plus negative I cancels to 0. So the sum is 4. To get the product, I'm again going to FOIL. So I'm going to get rid of the plus and I'm going to multiply them together. When I FOIL these, again, I have the conjugates. Well, 2 times 2 is 4. The middle terms cancel out. And I times negative I is negative I squared. Now think back to our work with complex numbers. I squared is equal to negative 1. So what we have here is 4 minus negative 1, or 5. So the product of those two roots is 5. So putting that into the formula, I have x squared minus the sum times x plus the product, and we set it equal to 0. So that is my quadratic equation that will give me the two roots, 2 plus and minus I. Here I have 3 more examples. Go ahead and pause the video, see if you can get them right, and then we'll come back and talk about them in a minute. Okay, looking at the first one, negative 3 plus 1/2 is negative 5/2. The product of negative 3 and 1/2 is negative 3/2. So we have x squared minus the sum, which would be a plus 5/2 x, minus 3/2 equals 0. And remember, in order for this to be in standard form, you can't have any fractions. So I have to multiply by the denominator of 2 and get the 2x squared plus 5x minus 3 as my final answer. Make sure you're always setting those equal to either 0, y, or f of x as well. In the next one, 4 plus or minus 2 square root of 3. Those two roots are 4 plus 2 square root of 3 and 4 minus 2 square root of 3. When we add those together, we get 8. When we multiply those together, we have to FOIL, and we end up getting 4. And our final answer is x squared minus 8x plus 4 equals 0. And the final one is a complex set of roots. When you add those together, you get 12. When you multiply those together using FOIL, you would get 38, and you end up with x squared minus 12x plus 38 equals 0.